Oh, so now we are starting. So the beautiful introduction that was not recorded, I won't repeat. But my idea is to start talking about a little bit about me, like many people do in meta seminars, to understand from whom this presentation comes from. You've seen me around, I hope, and if you're new or if you're old but you haven't seen me around, I'm Federico Grasso Toro. I come from Argentina. I have a engineer's degree in electronics and automation. Then I did a PhD in artificial intelligence applied for satellite systems in Germany. Then I did a master's in storytelling and performing arts in Turin, in Italy. And then after that, I went to PTV to start working in legal metrology, where I started a postdoc in ontology of knowledge for metrology services. And then I stopped because I noticed that I needed to focus a little bit more on what digitalization would do for metrology. And here we are. I'm doing digitalization for METAS. So let's go to the first slide. Hopefully you see there. And this is a list of topics that I would mention or talk about. This looks a little bit boring, but I did this on purpose for you to see what we have here. It will go from the introduction of digitalization. What does that mean? It's important. A lot of people are having problems realizing the difference between terms like digitization and digitalization. Then we'll talk a little about the digital trends and how that is affecting or will be affecting metrology in general. Then we go a little bit about what I've been doing since I started in METAS, that is to focus on a METAS-centric digital strategy. And from there, what I started, I think it was July 2019, the METAS digitalization project of, as some people might know it, development of AI toolbox for metrological services. After that, I will mention a couple of open potential research topics that I believe we need to have in mind. If this would have been longer face-to-face discussion, this would have been the part that I would open the floor and start discussing topics and why I believe they're important and why you believe might or might not be important for your lab and so on. So we'll see. And then at the end, we have a summary and conclusion. But I'm going to try to do something different this time around. I'm going to try to use a way of keeping your attention in the thing, because if you're explaining something new to someone, it's very easy for them to just get lost. So what I'll do is I'll use taglines or tags, or as many people call them, hashtags, for you to remember specific stuff. So the only thing that I can promise is at the end of this meeting, that I would have hoped to be like a very long coffee break between you and I, you will remember 2, 3, maybe even 4 hashtags. Those hashtags in your head would be the topics that you're more interested about. So it would be okay if you send me an email with those hashtags, then we can start a conversation, not from nothing, but for one specific thing. So let's try that out. The hashtag for this slide would be just to have the content of it. So if you want to talk about this slide, just keep in mind content, because basically a hashtag would be an easy way for us to understand the concept of metadata. That is something that I also work to try to convince people that is useful. And in this case, the metadata of this slide would be the content. And for example, on the lower side of the slide, I don't know if you can see that in the share, we would have a date. So those are the 2 hashtags that you can keep in mind if you're interested in talking to me afterwards about this slide. Let's actually, from now on, the hashtag will be actually useful. These are just for you to understand the concept of hashtag within the presentation. So now that I spent almost 4 minutes talking about how we'll deal with this, let's have this coffee break or virtual coffee break, me to explain you what's going on here. So the first thing that I've noticed many people having problem with is to differentiate digitization with digitalization with digital transformation. And the problem is clear, especially in German, because Digitalisierung is just one word, but means digitization and digitalization. So please let me explain this. And if you keep something from this seminar, maybe, hopefully, this is it. Digitization is described as representing in a digital way something that usually comes from an analog input. So an easy way to understand this is, look at this machine. This machine takes books and scans the books into a scanned version of the books. This is digitization. This I don't do. I might know how to do it, I'm not really sure, I don't do. This is not what I'm trying to do here in METAS. Now let's go to digitalization. So digitalization, in the other side of things, is usually described as to try to find new markets based on digital technologies. So basically, now that we have different technologies, can these different technologies affect my business? And if they affect it, should I wait for the effect to happen, or should I get ahead and plan what kind of new services, of new products can I develop based on the new digital technologies that are happening? That's why it's so important, at least in my work, to be always aware of trends. So this is a definition by the Gartner consulting company that's basically pushing a lot of concepts such as digitalization in part. And now let's go to a clear example. Google Maps is the digitalization of a map. It's not the digitization of a map, it's the digitalization of a map. Because you know, Google Map is not just a map. It gives you added value by means of different kinds of functions that do not exist in a map, but they exist in a digital map like Google Maps. So this is the thing that I should be trying to do, and what I'm trying to do within METAS. So if this is clear, now let's go to the question of then what is digital transformation? So digital transformation is, at the end of the day, the calculation and the assessment of the actual effect of the concept of digitalization. So at the end of my project, hopefully I will be able to have a report that would be the digital transformation perspective. That is, by means of digitalization, these could be, or these are the effects in long and short term, short and long term for METAS. So now that we see this, let's see an easy example. What if I take a map and I scan it? So this is a scan map of South America from, I don't know, the 90th century. So if I have this as a file, I have a map of Argentina, Chile, and every other country there. But that is the digitization of the map. It's not the digitalization of a map. The digitalization of the map can show me, if I Google in Google Maps my home state of San Juan, Argentina, that an earthquake happened last week, specifically at this time, 42 kilometers from my home. This information cannot be in the first map, but should be part of this second map. This is the difference between digital and digitalization service. So the digital version of the map cannot give me this service that digital maps can give me. Now that I said this for like 4, 5 times, you can have in mind this difference in order for you to think within your work in METAS, how can I apply this metaphor of map and Google Maps? This is the starting point for a conversation, I believe, because this is what I'm going to try to do in the remainings of my project with all labs that are interested in. And now we have a cool first hashtag. The first hashtag is dig, because it's digitization, digital transformation. So if you want to talk about this difference and what that does mean for metrology, just remember this hashtag, dig, and send me an email about dig, and we can talk about it. I hope this one is easy to remember. So now that we know that, instead of going to the actual specific examples, let's go abroad and think how the digital trends are affecting these areas. So for example, we have all these people trying to do new cool technologies approach to industry. We have the Gigafactory of Tesla. We have this Jax Motors self-sustained factory concept. And all this stuff sounds cool, but the question to us is how does these new trends, these new digital trends, will affect the metrology aspects of these businesses, and those metrology aspects of these businesses should guide us where to go service-wise. So in a mega self-sustained, super cool factory, problems of metrology would arise regarding the digital trust. So basically, how do within the company they can do stuff that how they can do their own traceability within labs if they are all one network connected, for example, and stuff like that. Then we have the AI metrology, as people are calling it, the new type of metrology, that is how can we evaluate a system that include AI as part of the process in order to say, can we certify them, can we validate it, and so on. And also stuff like, if, as I said, if this is a one big network, how can we consider measuring sensor networks like just one device in order to be able to monitor them, edit them, control them, and so on. So these are new problems that digital trends are coming up with. So these are the types of metrological needs that we need to take in consideration when we think digitalization of metrology. Now, this is stuff that I did for the first 6 months while I was in METAS to find these trends, to explain in METAS, specifically regarding the resources of METAS, which kind of needs we'll need. So this is industry, so most of the time our customers come from industry or manufacturing, so we need to think about this particularly well. For this, we have the hashtag #DigTrends. So if you're interested in talking about digital trends in industry or in other aspects of normal life, please remember the hashtag #DigTrends. Another aspect that many people are focusing on is smart cities, as they're called. And an example for that I stole from Intel and Bosch is how can you evaluate a whole city as one big measurement device for air quality? And this is a big question because it opens up questions about what some people are calling urban metabolism metrology. That is just basically how can you measure, trace, and trust the measurements of not just one area, not just one network, but the whole city as a network of networks. So these are open topics that the new trends and open it up. So us as an NMI should be thinking, are we equipped to go that way? Are we interested in going that way? And from there, we can start developing those Google Maps options that we can have for our own services. Also, in this case, since it's also a network of sensors, the metrology for measuring sensor networks would be also included. So remember, if you want to talk to me about specific digital trends, the hashtag is digital trends, and of course you'll have the slides so you can just look at them, read them properly. Right now, this is just a coffee break, and we are talking for like an hour. Another topic that is, to me, very interesting is how some people are focusing on a digital ID, and how are they considering digital ID one specific part in order to provide or not access to specific types of services within a company. So that example that I show there is identity access management, or ID as a service. As this is a proof of concept that people are showing around. You can see the source there. And the interesting part about here is that where do we find metrology is a bit new, because we have, for one side, the human metrology, that is how people are calling the metrology or the traceability of biomarkers or stuff that identify as ourselves. If you have a phone, you know what a fingerprint identifies of itself. But then that would be from the part of the customer, that is basically the person working within the thing. But what about the employee? And how can you describe within a complex network digital trust of the actual community created within this identifier network? That's a question. These are open questions that are going a little bit more about IT than a bit about any other service, but is another potential new metrology that we need to keep in mind. So remember, if you're interested in talking about all these topics with me, because something that I just mentioned wakes up a question regarding the thing that you're actually doing in METAS, and you're thinking how that thing would evolve, send me an email with the hashtag #DigTrends. So now that we've said that, I'm wondering probably the same thing as you. What other NMIs are doing with these digital trends? How are they facing these digital trends? And I did this summary. You can read it afterwards. That is, the big ones are, or the different ones are trying to approach it in different ways. A short way of explaining this is NIST specifically is considering, this won't be written like this, but remember, this is a coffee break, so I'll make it more informal. NIST is basically believing that they can create their own Facebook, but just for manufacturers. So they're trying to write services a la carte. So they create profiles for manufacturers, give them favorite services, and based on that, they create models of customers in order to optimize. Very similar to what Facebook does. MPL is focusing a little bit more differently, because they have the idea to just basically become the enabler of digitalization in industry. So what they're doing is they're going to industry and saying, what do you need in order to finish those digitalization projects that you're starting from the point of view of metrology? So they're learning by doing. And then PTV, I come from working in PTV for a couple of years, so I kind of seen this very close. they're just throwing a lot of spaghetti to the wall and seeing what sticks. So basically, they are producing as many projects regarding digitization as they can, and after 2 or 3 years, they see if this moved something or this worked, and if it does, they collect that, and with that, they're sort of opening up a new division called digitalization, from where they are sort of expanding potential projects. Then LNE is interesting because there's a report that came a couple of years ago in France that says AI should be the force for France. Therefore, AI should become a priority in France. And in that report, the guy that wrote this set all institutions in France saying what should they do. In that report, he takes LNE and he said what they should do is directly focus on AI evaluation, because from now on, AI would be part of many instruments, and they need to be able to do the same services that they did before, but not with classical instruments, but with AI aid instruments. So now that we have all this idea, now probably you'll ask, yeah, but Federico, what about METAS? And here's the question of how can we use, with our resources and with our size, a good approach, an interesting, complex, or at least well-combined strategy for us to not be followers, but at the same time not be too focused on stuff that we cannot really develop in so few years. So the first year of my project was to focus on these specific strategies. I said that we can do technology like some other NMIs are doing, but we need to focus on technologies that we already have. So new technologies that we have are going to be our guidelines towards technology-based services. Then for the services themselves, the big important thing for us is to be sure that whatever new service or whatever expansion of the service that exists right now doesn't make us an island. So we need to be very in control, or at least very well connected in an international community. So whatever we do fits the international needs, but at the same time fits the international path that we're aiming for. So for that, that's why for the first year and a half, I've been working so hard to make METAS relevant, or at least present in many international technical committees in a European and now worldwide level, just to make sure that we don't get isolated. And that finally, we go to the actual models. We go to the, okay, now, what do we need for us, from ourselves, to start making all these AI-based things that might allow us to do new services or not? For that, the interesting part for me was that when I wrote the project, I said, well, each lab has measurements, each lab has data, and each lab has a way of doing their own data analysis. So just allow me to see the analysis that they're already doing, and then I can offer specific new versions or new advances in data analysis for each of the labs. And what I learned, this is what I assumed while I wrote the project. What I learned is that it's a little bit different than I expected. There's no specific way of centralize or understand it between each other, everything. And that, let's say, open up a new requirement that I didn't know existed, for us at least. That is, we need a research data management policy. Many NMIs, specifically in Euramet, are focusing on, they realize that this is missing, and this thing called open science is coming, and they're requesting these FAIR principles to make it findable, accessible, interpretable, reusable. People don't know what they mean, but also they don't have internal policies to know how to do that. So knowing that, this thing was added into my project, because I realized that if we start doing research for research's sake, or if we start doing research just because I believe we can do new services, but we don't integrate it in a clear way within METAS, then the research also would become isolary, and it would be just a nice proof of concept, but it wouldn't be extendable, and so on. So my philosophy for whatever we are going to do next has to do with this, what I wrote underneath, that says the future of calibration from my point of view. And this is important to make clear that it's just my point of view. I believe that the future of calibration, as many future of metrological services, is going to be a combination of human plus machine. And if you're interested in talking about this, remember the hashtag METAS digital strategy. But if you're interested in talking about human plus machine, the hashtag human plus machine there, I'll explain it very quickly as how I see it and how we should keep in mind this for everything. So as I said, this is just my vision. So this is not the METAS vision, and this is not the METAS strategy. This is my Federico Grasso Toro's vision of how calibration services or any kind of metrological services should be in the digital age. The first thing is remember how we used to think. We had human, we have the machine, and it would be very easy for us to separate how the human controls the machine. This I took from this 1978 paper. I believe that in the future, we can synthesize all of it together as one main system, human and machine. And the whole thing would allow us to have a better, clearer, more optimal process within a human plus machine, let's say in this case, calibration service. So that idea, I believe, should be something that we keep in mind, especially all the labs here that know that the human cannot do the process alone, and they know, and this is something that people are afraid of, so it's good for us to explicit this here, the machine alone will never do the thing completely. So the question is, if the machine is going to do more and more things, what do the humans do in order to integrate within this human plus machine? Remember the hashtag human plus machine. Again, if you find me in the cafeteria or if you want to send me an email about this stuff, I'm happy to talk about this because I believe we need to think about this for the future. This is from a book that is called Human Plus Machine, The Future of Work. And from there, they said between humans and between machines, there's a middle ground there that is not completely clear. There are human complementing machines, and there are AI, for example, giving humans abilities or capacities that humans without that aid were not. So the idea to focus there is what can we do there in order to establish human plus machine services that make the human not to do more work in less time, but the human to do the same amount of work in the same amount of time, but having more time to think because the machine does the things that the human cannot. Oh, sorry, the machine does the things that the human does not want to do, repetitive tasks, and the human does the things that the machine cannot. So again, this is a little bit out of topic, but remember, a METAS seminar should be about you thinking about stuff. And this is something that I'm very aware of, and I'm looking forward to see if people are interested in talking about this. So now let's go back to METAS itself and what METAS considers their own digital strategy. And this I took, and you'll see it below. This is the source for when what was her name? Beat Jeckelman presented as part of a description of the project of digitalization that we were planning to do. And this I like because it's easy for us to identify that there's two specific things that digitalization can do for metrology: the digitalization of metrology or the metrology of digitalization. So before explaining details, let's go into the interesting stuff. Digitalization of metrology would be, we have metrology, we have metrological services. How can we use digital technologies in order to make them newer, better, bigger, more complex, less complex, that. Meanwhile, because there's a lot of digitalization happening in different places, as I showed before, in industry, in cities, socially, and even individual with our smartphones and stuff, that is creating new types of metrology. That is what is called metrology of digitalization, that is focusing not about services that existed that need to be upgraded, but services that did not exist yet, and now we are realizing we need. So for digitalization of metrology, yeah, I think is the obvious thing, is the digitalization of calibration services, is the standardization of research data management in order to have open science, fair principles, and at the end of the day, and I think this is the main topic that would affect, and again, this is my belief, that would affect people at all levels in METAS in the future, is that we will become a little bit more data-driven and that decision-making driven. And this is interesting because different data would be needed for different types of decision-making. That's why I want to open the dialogue from today on to anyone in METAS that is interested in this, to realize at their level, whatever level that might be, whatever lab they might be, how they would be affected and benefit by the means of collecting properly the data that allowed us to do new type of decision making. Decision making would be, if you know your setup is in a specific way, maybe you shouldn't do this measurement today because you know enough about your setup to know that when the setup is like this, maybe you should focus on other stuff and you try tomorrow, depending on environmental conditions and stuff like that. And then the metrology of digitalization is all this stuff that is so confusing because it has nothing or very little to do with metrology and has a lot to do with the rest, with AI, with big data, with Industry 4.0, with digital twins, and so on. So now that you see this difference, please make sure that I'll make hashtags about it. So I don't know where the hashtags went. There we go. Here it is. So this is still METAS digitalization strategy or METAS dig strategy, but now you can specify a second hashtag if you want to focus whether in the digitalization for metrology, dig for MET, or if you want to focus on the other one, metrology for digitalization. So not to update things that existed, but to create new things. For that one, it's MET for dig. Keep them in mind, and then let's keep moving because this is going, they're going well. So now that we've said that, let's start with easy examples, clear examples, already active examples. What are we doing within the calibration certificates in the digital age? So calibration certificates exist, will exist. The question is, what would be digital calibration certificates in the future? So for that, I have a nice example that is, I call it the Swiss Digital Calibration Certificate, and it has a little story. A year ago, we met in Bern with a technical committee focusing on development of digital calibration certificates. And PTV had this idea, had this project, and said, we have the solution, we need to use only this. And the discussion that day was, we don't believe that we need to have one single solution. We believe we need to have rules. And if we have rules that we end up calling the minimum requirements for digital calibration certificates, then any NMI can solve their own certificates based on whatever they need or based on whatever they have in their own institutions. So we did these minimum requirements, and based on that, we are developing this Swiss calibration, digital calibration certificate that is getting more track because they are noticing that by covering this basic stuff, it's enough. You don't need to follow procedure, you just need to follow requirements. So for that, this starts with an example with an anonymized email to Marc Olivier with someone asking, can we have something more? So I translate it here from a manufacturer. Do we have the possibility of getting not just the thing, there's someone with the microphone on. So can we have the possibility not just to have the calibration certificate, but also to have the calibration results? I don't know, in an Excel file, he asks. So this, again, and because you work in METAS, you know, if we have a service focused on a case-by-case base, this can be solved. But it's not a standardized way of solving it, and there's not a standardized way to actually start providing that service. So if a manufacturer gets a certificate from you and asks you for added files, maybe you can send it by email, but that's not properly standardized, that's not properly part of the service. So following the minimum requirements of a digital calibration certificate, we said, can we do a certificate that's still a PDF, that is still signed, so that's legal, but it contains files inside the document. Therefore, we can provide those Excel files that they want, but they're inside the document. Therefore, they are protected by our signature. Therefore, they are a new type of service. It's not just the typical PDF that you send, it's the typical PDF you send plus additional information inside the file that the customer might need. So you see, now it's a different service. It's not the typical certificate you give, it's a type of certificate that is the one that you had plus additional information. And then the question is, since we're going to do it like that, can we focus on make it not just human readable in the PDF, but also machine readable? And an easy way to say that is, can we create metadata, so data about data, within the certificate for a human to read it and understand it, but for a machine to import the metadata and record and save the calibration certificate in their own database. And this is what we're aiming for. We're doing prototypes about that. We'll talk about that later. Now, the other value for that would be that this certificate is not just following availability, integrity, and confidentiality, that is like the most basic IT requirements, but it's also providing additional value that follow what we agree in the meeting in Bern a year ago. A digital calibration certificate should have as minimum requirements or a minimum extension of services for a customer. in part of our technical committee from Euramet. If you want to talk about this, of course, the hashtag is DCC. You ask me about this, and we can talk about how a DCC would affect your work specifically regarding the procedures that you're doing in your lab. So now let's focus on another type of service. That is, as I said, we decided to focus on technologies that we already developed, and one of those technologies was the BRDF, so appearance in optics. So for that, the idea was, by seeing what you're having, the example in itself was, can we, by the collected data that appearance has, especially in the setup of Mars, focus on creating data and knowledge-driven services. What does that mean? The problem is, you have Mars there, you collect a lot of amount of data, and have not enough metadata to actually start thinking about what that data is, because that's just basically the results. And then you write a measurement report, and that's what the customer asked for, so that's enough. But what if we focus on, by collecting data and analyzing the data, not just from one measurement, but from different measurements, to find patterns in the types of surfaces that you're measuring, so the types of appearances that you're measuring, and at the same time to realize that with less amounts of measurements, you can have the same kind of quality result, the same kind of result. The question is, we need to specify the types of quality. We need to specify the types of cases. And for that, we need data, we need a lot of data analysis, and this is what we're doing. The idea for that then is then we can focus on, by collecting a lot of data, recognize known cases from measurement, from previous measurements. And if we know the type of measurement, we can slowly standardize how to deal with specific surfaces. This is an idea that can only be proven empirically. So a lot of measurements, and then see to interpret the cases from the measurements. Then, by knowing that, and by knowing that we can collect X amount of data, 100%, 50%, 70%, and we can define different levels of quality of the data towards the end up result, then we can offer the customer not just the service of measuring, but the service of measuring with different levels of quality. So we are expanding the possibility of services to provide just by doing the data analysis underneath. So we're not creating a new setup to create a new service. We're taking the same setup, we're doing a little bit more for post-processing, and then we are realizing we can offer different levels of quality, therefore different levels of precision, different levels of quantity, amount of data, different levels of service. So the idea there is that also by analyzing that, you can provide not just the data, but also valuable metadata, so information about the information for specifics for data science use, but specifically also for open science. That is, you learn stuff, you learn how to describe the stuff that you learn based on the stuff that you've measured. So it's not just the result, the stuff that you measure, but the stuff that you measure, what you learn about it, and how you describe what you learn about it. So that would have an added value of expanding one service right now, that would be a measurement report of Mars, or the appearance setups, to many services for measurement reports based on the quality, so based on the amount of data in order to describe the quality of the measurement, based on the end user base. So it's like is the end user a researcher? Is the end user a company? What are they using it for? For example, if they're using it for quality control, can we provide additional metadata, so data about data that would allow them to do a better quality control checking and so on. And of course, the idea is that the more standardized this data and metadata it is, the easier it is to say that we're open science, the easier it is to find it, to access it, to interoperable, so to make it interoperable, so to use it for further research and to reuse it, because that's fair. Those are the principles from which the European Union is focusing open science. If you want to talk about stuff like that, the hashtag is AI tools, and then we can talk about the examples that we've been doing for the last year and how that might affect or how that might translate to your specific lab. So with that said, now we are here. We have the idea of what do I understand as the project of digitalization. This thing that started, what was that, July 2019. That is, in my mind, because of the resources that we have and because of the technology that we have and because of the connections that now we have after a year of a lot of international work in different committees and technical committees, basically, is how do we focus or how do we see the digitalization project, or as it's also known, AI, the development of AI tools for digital metrological services. And this in green is my hope. I believe that METAS can become the first digital metrological service provider. Basically, right now, everyone's providing metrological services, but the moment that we standardize how we streamline stuff, we can say we are providing digital metrological services. Hopefully, based on the information that we're collecting and the potential development that we can do at the end of this project, we can say that we can aim to that as an objective, or my own personal vision of how the digitalization project should answer this question. That is, can we or not? And if we can, how? So where the next step would be, the first step, the first part of this whole thing is the project, as I said, is the development of this. I think we already talked about that. So here we have the whole description of how to start with the tools, then develop stuff. So these are the levels of complexity, and these are the most significant points, sort of like to create an interdisciplinary framework. So we are not isolated and we understand across the labs how to do this. Then update services. So from the digital technologies, what new services can we do? Then create a good platform of research data management in order to be able to create research that would be useful, extendable, and reusable, but at the same time aiming to try to find how in different levels of METAS, so in the lab, in heads of labs, in management, at all points, to be able to create new data-driven decision-making. That is, at the end of the day, it would be great if anyone has a post-process of the data sets that they're related to their work, and to see how things are going in a very quick, oh, we're doing not enough of this, yes, we're doing too much of that, stuff that allows you to decide stuff in the future. And basically, in order to do that, that would be like the starting, or to me, the perfect starting point for us to have digital services. And specifically, once we have digital services, we can expand to say we can acquire any kind of innovative system, and we can, because we have digital services, adapt these new digital services to unexistent or non-existent yet services, like how do you calibrate a sensor network for air quality? How do you validate the AI models for prediction about water across Switzerland, and so on? So if you want to talk about that in specifics, just remember DIG project is the hashtag. You can send me an email. You can put questions in the chat. We can talk about that later. So here we are. The idea, as Hugo said, was to give it a little bit of an update of where we are and how we are. So this is the updated objectives. I just described very quickly the objectives. These are the updated objectives for December last year. So you see here, depending on the color, is something that is advanced, is something that is next step or in the middle of becoming advanced. And then the ones in black are further steps. That are stuff that we know we need to do, but we haven't started yet. So, as I said, the first main objective is to create a framework for interdisciplinary tasks, something that allows us to say about this topic, we have different people from different labs aiding or helping to do the same. Or we do the thing and we test it in the labs, or the people in the labs are doing stuff and we are using it to share it across the labs. For that, we created some subgroups of stuff that I can show you later for specifics. And this is advancing, but we need new groups about specific topics. Then we have the development of demos based on data and knowledge. These are examples that I already showed, for example, for appearance and so on. And the dissemination of results through the groups. This is the next steps that we would need to focus on. That is, like, once we have something, can we scale it? Can we share it? And stuff like that. Then for the specific of the tools, the idea is, based on these demos, can we specifically create tools that would be useful, not just for the demo itself, but across. And the first one is this portable DCC exporter tool that we've done. I'll describe that a little bit later on. And the other one is the quality-based dimensionality reduction tool that I explained a bit when I was talking about appearance. So this is ongoing work. And the setup condition monitoring, that depends on the quality, and that depends on the type of information that we can collect about the setup. This is another example, but there were too many, so I didn't want to go into too many details, but this is the advanced. So if someone from management is here, this slide basically should give you the update of where we are at the end of 2020. And the third main significant point based on the already existing objectives is the measuring sensor network. And for that, we have done a draft of the minimum requirements of what a measuring sensor network should be in order for us to consider that one device. And then we need to think, if we can consider that one device, how do we do services within that device? So for that, we are aiming, but it's a further step to find collaborations to validate and verify these setups, these networks, may that be by AI or may that be by decentralized measurement devices. And then from there to develop proper models in order for us to use as part of our procedure. So this is way in the future, but it's important for us to have it in the update objectives because we're starting there as well. So if you want to talk about that, the hashtag is DIGProject, and then please just let me know or send me an email. I can talk about that in detail. Remember, the slides will be available after the presentation. Now, remembering, we are almost finished there, so please don't get too loose because probably you're tired. I'm tired. Everyone's tired. Let's focus on the almost finished part. There is open potential research topics. The question is, starting now in 2021 until the end of 2022, we would like to do feasibility reports. So tests in order to say this new technique, most of the time AI, but different technologies would be useful for this specific type of service and this specific type of lab. So for that, we would like to have a standardized way of doing it. And for that, I use this, and I think I showed it before, to analyze what a metrological service is for me. So over the period of time, the thing starts with a contract that includes a process that takes into request and planning, that includes a procedure, then you have the setup, then you have the measurement of the black box, then you have the evaluation of the results. The results tends to be on a certificate or on a report, and then you just give them an invoice, and that's it. So this deconstruction over time about the service, and the black box itself can be the device. Usually it comes to the lab and that's it. But in the future might be a censoring, an AI model of something. Can that be a physical, cyber physical system? That is when you combine the cyber part, so a lot of software with some measurements from the physical world and then the interaction with the human. So from that, I separated 7 topics. The first 7 topics that I believe we need to do research on. So you'll see the first 3 are the ones that I've already mentioned. So digital calibration certificates, models, and setup condition monitoring. So you'll see that all these 7 topics are not just because I think they are needed. They're also directly connected to the thing that I just described as the deconstruction of the service here. So the 4th one, I believe, should be focusing on more confidence reports. How can we continue evaluating the results in order to provide additional information about the results? 5th, it would be, can we, because we know well our own labs, create expert systems for assisting whoever is doing the service? So someone provides enough information for us to create like a flow diagram of how to do the service in order for them to be able to check if they're forgetting something or how standardized the way of serving it. And that would be internal for the lab, right? And then the question is, can we do that, but instead of on a black box, in a type of a box that comes with a lot of stuff that is AI, or that is an unexpected way of seeing instruments. Each lab, for sure, is seeing new innovation and is wondering, how do we evaluate that? And this is the question that I would like to focus on, the 6th point. And the 7th point is, can we consider the whole thing one thing, the cyber physical system? So you see all these numbers here kind of track in the process, because 1 is there in the certificate, 2 is there specifically in the black box of itself. The 3 is the setup before the actual measurement as part of the procedure. 4, that's the one that I want to advance on, would be the confidence report. So they would be from the evaluation and the results. 5th would be the procedure itself as a whole. Can we create something that helps you do the whole procedure and feel more comfortable about how you're doing the procedure? 6th would be, can we do different procedures based on different kinds of black boxes? And the 7th is, are there new types of black boxes that we should focus on? So for that, all of this is just a concept of mine. All of this is a list of potential research topics that I believe we need. And for that, I'm calling this hashtag PRT because it's potential research topics. Now, the question is, how do we do these feasibility reports that I want to do from now, so beginning of 2021 until the end of 2022? And for that, I'm using research by means of ontology of knowledge. Sounds complicated, it's not, it's just basically the postdoc that I was doing in PTV. That is, how can we do research and development with the labs, not and the labs, or taking the labs, or the labs do research and development and then they give research and development something. So how can we do work that together? And my approach is we separate it in levels. The first level would be data. In the case of a feasibility report, the data would be scientific publications. You don't need to focus on that. I need to focus on that. Research and development should focus on that. From there, we should be able to filter information, proper information, actual techniques that we need to try because we believe they are in line with one specific thing that we need to do. From there, we create or we define or classify the knowledge. So for example, AI. I have a PhD in AI, so I have the knowledge about AI. But AI applied to acoustics. I don't have a degree in acoustics, but the people in acoustics know about acoustics. And then the question is, can we use AI to validate a measurement in acoustics? Then the question is, how can we do the AI? I'll help. How can we do the measurement acoustics evaluation? People in acoustics will help. And then by combining all that, we can put that. So this is the first step. The second step would be, do we have enough expertise? And then the question is, can we reproduce what we've collected from the scientific knowledge, so from the papers? And if we can reproduce it, how feasible that would be for us to develop it as part of our lab or as part of our institution. So then at the end would be the feasibility report, or what I call the content, so the result of this ontology. This feasibility report would contain, within a specific chosen research topic, yes, is this feasible or not, for METAS regarding specific requirements for research data management, but at the same time, resources that we have. And if we don't have enough resources, we can calculate as part of this result, which resources, meaning which type of size and which type of scope this project would have. Maybe the result of this feasibility report is, we need to do this as a bigger project. We need to do this as a smaller thing. So that is, we can do it as an internal project, we can do this as an MPeer project, and so on. So now that we have this, I have a long, so this, the hashtag of this is OK, so this is ontology of knowledge. If you're interested in this, please ask me about this. Now that we have this, for each of the topics, we have the things that we're already being developed for the DCC. We have the things that we're already developing for the ongoing data and knowledge-based tools, the things that we're doing with Appearance, the things that we're starting to do with CT, and so on. But the interesting thing for me, so this, as I said, is the stuff that we are already working on. So this is what we can call, this is not a PRT. So this, finally a mistake. So that hashtag there is wrong, because this is what the things that we're doing. Focus on the feasibility report, on the things that we have done already, the feasibility reports. So frameworks for interdisciplinary task, that's the idea of, can we focus on doing one thing, not just in one lab, but in many labs? That's the hashtag there. And in the example here that we're already focusing on, this is already developed, is DCC, and the other ones are AI tools. Keep this in mind. If you're interested, send me a question. But then this would have been the fun part about the workshop, because this would have opened up the discussion and said, okay, let's discuss topic by topic what I believe from 4. So I will explain what type of measurements or what type of techniques I would believe would be useful, like Bayesian processing model, or cyber-physical human systems, or even the post-processing by Mahalanobis ellipses, all this stuff. And we would have discussed, yes, we've developed this in this lab. We don't want to develop this in this lab. This would have been the part that would have made this presentation a workshop. I'll keep that information there. You'll have the hashtags for each, and you can check it out. And hopefully you're interested enough for these specific things for you to send me an email saying like, yeah, this expert system thing about collecting data from the lab in order to learn reasoning for the processes, I'm interested, send me stuff, and then we can focus lab by lab, or even people by people, person by person, something that might be interested or not. So I'll leave all that there with details. This is an interesting one for you to see the difference between digital twin and, because you hear digital twin, and I put information there between a digital model, a digital shadow, and a digital twin. So check all that, think about that. We would have discussed this face-to-face, but these are weird situation of times. So all that information is there. Now let's go to the summary. So the summary is, hopefully you had an idea about digitalization, digitization, and digital transformation. Remember, if this is still confusing, ask me, I'll be okay answering as much as I can. Then we have digital metrology as a short and long-term question. Remember, digitalization of metrology, digitalization of calibration, integrity, measurement sensor networks, research data management, or the metrology of digitalization. These are the things based on big data and all this other stuff, simulations, digital twin, all this stuff. Check the slides if you're interested in the stuff. Send me an email with the hashtag or and we can start the conversations with actual meetings. Meetings by WebEx, we'll see. And then Industry 4.0. So remember, the hashtags would be regarding digitalization, digitization, and digital transformation, dig. Digital trends about specifics, that industry will see. About the METAS digital strategy, please send me that. And then digital for metrology, so dig for met, or metrology for digitalization, met for dig. And then the final part is all this stuff about long-term that we would like to focus on is to establish this framework, to focus on research and development and application for data management plan, all this fair stuff, all these things, the tools that we have for knowledge transfer within the labs, the information theory that we're using or not, all of that stuff does not exist. All of that I'm interested in asking you. So the moment you are interested in the stuff that I said before, I'll have a meeting with you and focus on which kind of demos should we start doing, which kind of demos are we finishing, so I can show you what we're finishing. And then the big question is, would you be interested in participating in writing with us or planning with us these feasibility reports in the next 2 years? So, big project, framework for interdisciplinary tasks, research data management. If you're interested in that, let me know. I can send you the presentation that I did last week of me talking 50 minutes without stopping about research data management and principles and so on. So all these hashtags would be there. So, So thank you for your attention. I hope this is enough information for you to start thinking about it and asking me questions. Hugo?
Yeah, thanks, Federico. There was a lot of information, of course, and we have also some questions. So I would like to ask you several questions. Sure. So the first one was from, I don't know who that was, but this person asked, given your knowledge on the diverse nature of services provided by METAS, as well as its structure and the many research projects underway, which area do you consider as in most need of digitalization approaches? Please
okay, so
please name one or a few, or give an explanation.
There's always many, but I like the question of what should we focus on the first. And what we should focus on the first is the base for us to create the stuff. And that base I'm calling research data management, because it's not just research data management. You can use it for research, but you can also use it for your analysis of your own lab. So to me, the first step, and you'll see it, Hugo, because in 2 weeks I'll send you a draft of a METAS research data management policy that I believe we should focus on in order for us to standardize how to collect data, to teach the people how to create metadata, so data about the data, for us to start creating this database, basically, of METAS that would allow us to improve and advance in digitalization systems. If not, we're going to have little systems that are not going to be connected. So to me, the first thing that we should focus on is research data management, fairness, open science, basically.
Okay, clear example and very fast answer. Thank you.
Oh, yeah, sorry.
there is another question from Philip.
Yeah.
At AI Tools, he remembers the hashtags. Based on your BRDF example, what is your concrete achievement to date?
Yeah, concrete achievement to date. And it would be nice if Nina says it, because Nina told me yesterday about this. But if I remember correctly, what Nina told me yesterday, right now, because of how we changed the way of collecting the data and because we have the change of the way of how we analyze the data, we can easily plot different types of surface. And because we know for different kinds of surface specific uncertainties, we can know when a new surface comes that is considerable known because it's similar to, let's say, it's a white and it has specific things. We have a better approach of how to do the measurements because we know how to analyze them later. So this is the examples that if this would have been a workshop and Gregor Boschum would have been here, he would have shown those plots to specify the case pattern recognition and how associated to that we can now analyze the different kinds of level of quality. So I hope, who is it, Philip? I hope that's a good summary. Again, send me the link, send me an email with that, and I'll write it properly. And probably with Nina's corrections, I won't be saying it wrong.
We have all the questions. So there is another interesting question by Daniel Sprecher. Is the concept of traceability affected by digitalization?
Yes,
he gives in even an example. Digital technology offers the possibility to classify the results of a smart sensor network as traceable to SI units, which would not have been the case in the traditional way.
Right. I would modify that to should offer the option. I'm not sure that right now they can, but let's say yes, they will. So yes, the idea, and this is an interesting question about how are we dealing with our own traceability, because all of us know the little pyramid thing and how we trace up the pyramid, and as digitalizations allow us to not be so static about it, allow a customer that has a future digital calibration certificate to check traceability up to the key comparison database. These kind of things would create something that I didn't mention because it's too much information. One of the extended reports that I would like to add to measurements, that is, we have the measurement, but we also have something that I'm calling a traceability report. That is, with the digital means that we have, how much traceability can we share with the customer about the value that we've measured? So yes, that's the idea. We need to advance the traceability, or let's say to do digitalization of traceability, not just digitization of traceability.
Okay, let's go to another question also.
Yeah.
About traceability. Bernhard Niederhauser, he asks, how can the most important concept of traceability be explained for AI-treated data?
What does that mean? Let's go again. The most important concept of traceability be explained by?
AI-treated data.
Okay, I see. So what you're asking is, how can we do traceability if in the process there's AI?
Yes.
And this is something that we've been dealing with in the OIML D31. That's a document for software in measurement instruments. And what we've done is we've created a list of new types of identification called dynamic identification for us to have something like a digital fingerprint of the AI that is doing that part. So you sometimes, depending on the AI, you can simplify it as a deterministic description, and therefore it shouldn't have been an AI, but sometimes you can't. When you can't, what you have is you analyze the process in a frequency analysis. So you put inputs and outputs and you see that black box, how it behaves. And based on that, you save the AI as it is at that point. So you say froze it as it is at that point, and that gives you a fingerprint, or a digital fingerprint, sorry, that allows you to identify what the measurement had happened. So what the result means from measurement to post-processing in AI. So again, we wrote that, let's say, recommendation for software. It's been probably gonna be approved this year. With in mind thinking new innovations that would come up. So this, as soon as innovations come up, we can test if this requirement is enough. So I'll make sure that Bernhard sees the new version of D31, so he sees how we are focusing on allowing traceability when AI is involved.
Let's go on to the next question. There's a question of Julian, sorry. He asked about the PDF certificate which can be produced. Which format is that? Is that a XML format? And is there a definition about the format and the keywords that will be used within this?
This is, I think we're missing concepts there. So the certificate should be human readable, therefore it tends to be a PDF. When the certificate should be machine readable, this is the question of standards of formatting. So he's asking XML because for years PTV had said, we've created this XML scheme, we need to use this XML scheme. And the agreement that we have in a European level right now is that that XML scheme is a solution, is not the solution. Because specific people are defining, so specific areas are defining specific fields. A good example is the SenseLab project that optics have. They have a specific type of XML schema that they need to include. So the question for you, Julian, the answer would be, we define the format based on the use of the specific field. If you ask me, XMLs in the past, we should do JSON, but it doesn't matter. It's a talk. It's an ongoing talk. The question is, how is the customer going to read it? So please, let's keep talking about that. Yes.
Yes. Okay.
But we're following the minimum requirements, and by following the minimum requirements, you can solve it as you want.
Okay. Let's go on to the next two questions. There is one of Christian Hoff. He asks about DCC also.
Yeah. Okay.
What could be the potential benefits of non-standardized digital certificates? Are you aware of the limitations of the concepts of digital certificates as they are being developed by PTB, which could be overcome by a METAS alternative?
Oh, that's a question of overcoming. The idea is, let's say you have two labs, one in METAS, one in PTB. Both of them provide the same calibration certificate, but METAS provides post-processing analysis of the results, and PTB just provides the results. So a customer can say, I want to do the post-process analysis. I would buy the option of PTB because I'll import the results and I'll post-process them. Or the customer can say, I kind of know Christian Hoff, and I know the type of analysis that he does. So this kind of new service is not just the calibration certificate, it's the calibration certificate plus Christian Hoff's post-processing of the measurements. The question is, what is the customer going to require, not what the standardized ways of doing it. Because standardized, we are following already existing standards. This needs to be there, this needs to be there. Everything else that we are adding should be added value that would give us an extended service, not the actual service. The actual service we cannot touch. What we're doing is adding stuff. And then the question is if PTV in acoustics is doing stuff that you're not doing, that's great, because you can do stuff that they are not doing, and now we have an open market with different kinds of services. I hope that answers it. If not, next time I see you for a coffee, I'll go into detail about that.
Okay, so let's come to the last question from Stefan Horrender. He wanted to know, what do we disclose under the FAIR principle? Do we just disclose the published data, which is a no-brainer, but all the raw data, CAD drawings, COMSOL models, etc., this has to be discussed?
Yes, I agree. Friday, I gave a lot of information to MPR coordinators about how do we need to understand fairness or findable accessible. So the answer for you, Stefan, directly should be at least the published data and enough metadata for your published data to be findable. That's it. That should be it, minimum. Now, raw data, different, let's say the CAD drawings, let's say even the models that you use, all of that stuff depends on your consortium. So if in your project, part of the thing that you're developing that does not exist are models, and you want to share those models for people to use those models, then you define that. There's a keyword here called data management plan. It's something that starts before the project and evolves over the project. All of these I mentioned. Some of you might have been Friday with the TCIM 1449 tutorial. What I can tell you, Stefan, is I'll send you the link to that so you see the open questions. And for the last part that you said about should we have a decision about that, this is what I want to help METAS have with this research data management policy. That is, when we do research, this is the minimum that we should provide in order to be open science. But also, if we provide this other stuff, let's say models, we need to define specific licensing systems like in the European Union and so on. So I'll send you an email with the link, and then we can discuss fairness in detail. Stefan.
Okay, thank you.
I think that's it.
Thank you, Federico, for answering all these questions in 10 minutes. Huh? So then let's end with me pointing you to the next seminar, which also will be a webinar, in fact, and it will.
I'll stop sharing.
The 3rd of March, and it will be given by Guglielmo Frigo, and it's also speaking about some kind of digitalization. He will speak about smart metrology for smart electricity grids. Also at 10 o'clock, 3rd of March, in the same room. That means online only. So thank you, Federico, once again, and
thank you, everyone. And please don't forget to send me an email with questions, because I want to start the discussion in all levels. So thank you so much for everyone for your attention.
Goodbye.
Bye-bye.
Bye.
Bye-bye.
Bye. Hugo, I'll stop recording, and
Yes.
if you want, you can download that from the recordings in the web. But this is gonna take a while to be processed, so you cannot download it